I don't mean to be a Debbie Downer, but I do want to get both sides of this titanium story. So I wanted to ask you, what are the main downsides to the use of titanium? And also, on top of that, does titanium production have a significant effect on climate change?
So it's a good question, Puneet, that why might you not want to use titanium? And one of them right off the bat is just the cost of the titanium. We talked about that a little bit already, but it is definitely a statement that it's an expensive material. There's a reason it's not more places. So the question is why? Because titanium is not a rare element in the Earth's crust. I don't know what its number is, but it's not outrageous. It's not like finding diamonds or gold in the ground. It's around. You can find it. If you find it in like swaths and patches, so much like strategic reserves and mines and things in countries that we may or may not be friends with. The similar things exist for titanium too, is that it's only certain places around the world, but it's out there. The question is, why is it expensive if it's in the Earth's crust in relative, in air quotes, abundance? And so when you look at how it's actually manufactured, something called the Kroll process, titanium is brought in, like I said, in rutile or a couple of other forms, and then it's broken down with a couple of methods, but typically is a combination of chlorine gas, and then you reduce that with, I think it's magnesium. You have this environment where you have chlorine gas, and then you have, call it tickle. Actually, it's a funny thing. It's TiCl4, so it kind of looks like tickle. So that's where it gets that name from. So when you think about the process that's used, you start to consider, like, is chlorine gas all that friendly? And the answer is no, not on its own, but we have engineering controls around that and you can deal with it. And then additionally, once you form that magnesium chloride salt, you have to essentially end up with pure titanium at the bottom of the reactor. And so how you do that is you react the other two ingredients, which were chlorine and magnesium, later together, and then get titanium out one side and a combination of magnesium and chlorine out the other. Both of those, best I understand the process, can be reused. So it's not like a huge waste. You're not venting the stuff to the atmosphere and never using it again. But it is an energy intensive process because between those steps, there needs to be distillation. It needs to be done at temperature. We mentioned in the Sioux City discussion, premium quality titanium can be melted up to 3 times. So then you're starting to use enormous amounts of electricity to do that. So I haven't seen the actual numbers on recycling of titanium just because it's less common than aluminum. But the reason, like aluminum cans, they have huge reason to recycle those is it's much, much easier to make an aluminum can out of an aluminum can than it is to make aluminum can out of raw ingredients of aluminum. So how it was pulled out of the earth. So that I would imagine the logic follows, right? That if you can skip all of that process of conversion into sponge and things, you're actually better off to recycle it. So its actual environmental footprint, I don't know that I am good enough to know those types of things, but the statement around, is it environmentally friendly material? The answer is probably not, because of the methods it took to get there. And then to recycle it, it would be much easier than to start fresh.
So last topic, I was reading an article about the weirdest things ever 3D printed, and I wanted to hear your professional opinion on this one.
Tom's business card was the weirdest thing I ever 3D printed.
I might have a weirder one for you.
Okay, let's hear it.
Researchers in Australia actually 3D printed lightweight titanium horseshoes for racehorses. But interestingly enough, they chose to make them a stylish hot pink color. So,
okay.
In your professional opinion, I was wondering if you agree with the color choice, and if not, which one would you choose?
You thought this was going to be a throwaway question, but the thing that we didn't talk about with the titanium oxide was anodization. So, here we go, right?
Wow.
So you can
we
actually
got technical here.
Yeah. I told you thought this was a throwaway, but it's not. So the aluminum, you can anodize aluminum, but what you require when you anodize aluminum is a dye. So the dye kind of fits into these little tiny like vertical passages inside of the aluminum oxide when you anodize it, and that gives you your color. I don't pretend to be a surface finishing expert. I leave room to be corrected on that, but the statement there is true, is that aluminum requires a dye to be anodized to a specific color. Titanium does not, and it all has to do with the thickness of that oxide layer. And you're talking about between tens and hundreds of angstroms of thickness of that material. And what you're actually looking at when you see a color is the interference patterns and some of the ways that light plays with that oxide. So I would guess, and I don't know the voltage at which these researchers anodized this titanium to hot pink, but for sure, that's probably how they got there. As to hot pink, I don't know, how colorblind are horses? You think it was trying to distract the race horses behind?
Ooh, maybe. That's clever.
Yeah.
That's what material science and engineers are used for.
I have nothing against hot pink. So if the horse or the owner of the horse wanted hot pink horseshoes, more power to him, I guess.
Another quick story there. Actually, I have a very close relationship with the anodization of titanium because we were doing our materials corrosion class and for a big paper at the end of the semester that we had to write. And we got assigned to anodization. And I thought anodization would be super boring. I did not think it would stick with me, but it's actually not. It's really cool. And so what we did for the class is we wrote our paper and we had to give a little PowerPoint presentation because that's the way you end any good college course. And
It's
our
good preparation, Tom, because no big professional meeting is complete without a couple of PowerPoints.
correct, which I've also learned that. But that aside, we decided to do a demo. One of my good friends had a spoon made of titanium, which they apparently sell. And what we did is we had a bath. It was full of some sort of salt dissolved in solution. I forget which salt, but I presume it was one of the very common ones. We essentially took the titanium spoon, took two wires, and I think we connected two 3-volt batteries in series, and we turned his right before the very eyes of the whole class, we turned his spoon purple. And we did not think it would work. And we started seeing bubbles, and we may or may not have mildly screamed, and it was fantastic. So,
Yeah, you can anodize with nothing more complicated. A bath of a couple of solutions. For the safety of listeners, I'm not going to disclose what those probably are. Batteries that you have in your house, you can get all the voltage you need to make a number of colors.
with your favorite titanium products,